Okay, so for number one, you're doing function analysis. You want to know if your outputs, how your outputs compare from function f and from function g. So for A, you're going to plug 3 into both functions as your input to figure out how your outputs compare. For function f, your inputs are your x's and your outputs are your y's. So if I plug 3 in, 3 is my x, and I get out 9. If I plug 3 into g, all I need to do is make sure that I'm following PEMDAS. So parentheses first, then exponents, then multiplication, and then addition. So I'm comparing 9 and 10, and this is asking me if 9 is less than 10. That is true. Do the same thing for letter B. I'm going to plug -1 into F, and I get out 1. And then I plug -1 into G. Again, you need to follow PEMDAS. So plugging in and following parentheses first, and then exponents, and then multiplication, and then addition. So now this question is asking me if 1 is greater than 10. That is false. Plug in 1 into F and get out 5. Plug 1 into G. Follow PEMDAS, parentheses first, then exponents, then multiplication, then addition, get out 2. This is asking me if 5 is less than 2. That is false. And now plug in 4. So I plug in 4 into F, and I get out 11. And then I'm going to plug in 4 into G and follow PEMDAS. And that is not true. 11 is not equal to 10. So you're just comparing inputs, or using inputs to compare outputs. All right, for number 2, you have a 4-inch by 4-inch, oops, that's the highlighter. A 4-inch by 4-inch square. So all sides are 4 inches. And then you're going to rotate this square around one of its sides. So we're going to rotate it like that. So that means on the other side, we will have another 4 by 4-inch square. And remember, you're rotating it 360 degrees around. So when we rotate this, we get a circular base on both top and bottom. You kind of need to visualize what this is going to create. This is going to create a cylinder. And then you just need to answer questions about the cylinder. They're focusing on like the height, the radius, and the diameter. So the cylinder is going to have the same height as the square. So the height will be 4 inches. The diameter of the cylinder goes across 2 squares. So the diameter is going to be 8 inches. And we know the radius is half the diameter, so the radius will be the length of 1 square, which which is 4 inches. Then we can answer the following questions based on that. The cylinder will have a height of 8 inches. That is false because the cylinder has the same height as the square. The cylinder will have a radius of 4 inches. We just said that was true. The radius is the length of 1 square. The height and the radius of the cylinder will be the same. Well, we said the height was 4 and the radius was 4, so this is true. And the cylinder will have a diameter of 16. That is false. We said the diameter will be 8 inches since it's the length of 2 squares. Right, more cylinder work. We have a cylinder that has a height. Ooh, let me try that again. Oh, that's still kind of bad at the bottom. Has a height of 24 feet and a diameter of 10 feet, which means the radius is 5 feet. We want to know the maximum amount of cubic feet that we can hold. That is just asking about the volume. This means you need to have the volume of a cylinder memorized. The volume of a cylinder formula is pi r squared h. And then you just need to plug in the information. So pi times the radius squared, which is 5, times the height, which is 24. Plug all of that into the calculator. I believe you get out 1884 feet cubed, round to the nearest foot, so no decimal places. But check my calculations because I'm going off of what I did earlier and my memory might not be so good right now. Number 4 is asking you to find the volume of a cone. So that means you need to have the volume formula for a cone memorized. That is 1/3 pi r squared h. So we just need to know the radius and the height. If the diameter is 4 inches, that means your radius is 2 inches. So we have 1/3 pi 2 squared times your height, which is 7. Plug all of that into the calculator. I don't remember what I got for that, so let me try to calculate that really quickly. And we want to round our answers to the nearest cubic inch, so no decimals for this as well. So that would be 29 inches cubed. And then for number 5, we need to find the volume of each shape. The volume formula is dependent on what kind of shape you are dealing with. So in A, we are dealing with a pyramid. The volume formula for a pyramid depends on what shape your base is. So I have 1/3 times the base area. Capital B is base area, not base length. So 1/3 base area times the height. This base is a square. So to calculate the base area is length times width. So that'd be 1/3, the length is 4, times the width is 4, times the height of the pyramid, which is 4. So I need to do 1/3 times 4 times 4 times 4. So that'll give you 21.3 inches cubed. And then moving on to a sphere, the volume formula for a sphere is 4/3 pi r cubed. Now this is saying your radius is 4, which means your diameter is 4. It's saying your diameter is 4, so your radius is 2. So we'll put 4/3 pi 2 squared, or 2 cubed, into the calculator. And we get 33.5 inches cubed. Okay, hopefully you remember the volume of a cylinder from the problem above. And yes, you need to have all of these formulas memorized. Again, the diameter is 4, so your radius is 2. Plugging all of that in, we get 50.3. And then again, I hope you remember the volume formula from a cone from the previous problem. 1/3 pi r squared h. Your diameter is 4, which means your radius is 2. And you actually don't even need to solve this one, because in comparison to a cylinder, we have the exact same dimensions. Our volume formula is 1/3 of that though. So we already know our volume is going to be 1/3 less than our previous answer. So we know it's not going to have the greatest volume. Nonetheless, if you're unsure, go ahead and plug it into the calculator, and then you can just compare the numbers. So 16.8 inches cubed. All you need to do for this problem is find the highest number now. The highest number belongs to the cylinder. For number 6, we need to use the law of sines because it is not a right triangle. And our options are the law of sines or the law of cosines. The law of sines is easier to use, so if we can use it, we should use it. And the way we know if we can use it is if we can fill in one of these fractions completely, both have numbers on both top and bottom. So it really doesn't matter which side and angle you label A, B, C, since it's not a right triangle. Right triangles, the longest side would have to belong to C. We just need to make sure that the side opposite that angle is the same letter. So across from angle A needs to be side A. Across from angle B needs to be side B. And across from angle C needs to be side C. And then we're just going to fill in with the information that we have. Now before we fill it in, I want to mention we actually have angle B, because we know that triangles are supposed to add up to 180. So if I add the two known angles together, I can figure out my unknown angle by subtracting that number, that sum, from 180. So I know angle B is actually 86 degrees. So now we can go to filling in this information. So I have set angle A to be 24, and I don't know side A, so I'll leave it. I know angle B now is 86, side B is 50, and angle C is 70, side C is unknown. What we're going to do now is look at these two at a time. So I definitely want to use this middle fraction because it's completely filled out. And the way that we solve this type of problem is through cross multiplying. So I'm going to multiply top and bottom, and set those numbers equal to each other. So A times sine 86 is equal to 50 times sine 24. And our goal is to solve for side A in this. So what we want to do now is divide to get rid of that multiplication. And then we can just plug all of that into the calculator to see what we get. These will cancel. So 50 sine 24 divided by sine 86, the calculator tells me is 20.4. And remember, your calculator needs to be in degree mode for this since the angles are being measured in degrees. So now we know jogger 2 is 20.4 feet away from the canoe. And then all we need to do to figure out how far jogger 1 is from the canoe is look at this set of fractions and do the same exact thing. We're going to cross multiply, and we'll get C times sine 86 is equal to 50 sine 70. We need to get rid of that multiplication of sine 86. So we'll use the inverse of multiplication, which is division. And that will get rid of sine 86 and allow us to solve for side C. Just plug that into your calculator now. And you get 47.1. So now we know jogger 1 is 47.1 feet away from the canoe. Okay, number 7 does not allow us to use law of sines because it only gives us the sides. And when we fill out our fractions, we won't have a complete fraction on top and on bottom. So we can't use law of sines. That means we must use the law of cosines. And yes, you do need to memorize your law of sines and law of cosines. They will not be given to you on the final exam. So then you just need to decide what A, B, and C are. Again, it really doesn't matter since this is not a right triangle what you decide A, B, and C are, as long as you label the opposite side from the angle the same letter. And now we just need to plug in what we know. We know C is 8, A is 10, B is 12, and we don't know angle C, so we're going to leave that alone. And then we're just going to simplify our math. So 8 squared is 64, 10 squared is 100, 12 squared is 144, 2 times 10 times 12 is negative 240. And then combine like terms. These numbers are not like terms with 240 because 240 has this cosine C attached to it. The other numbers do not have that. So we get 64 equals 244 minus 240 cosine C. And because 240 is not a like term with that, we need to subtract 244 from both sides. And I don't have enough room. Oopsies. That was that angle. Okay. So 64 minus 244 gives us negative 180. And that cancels. We have negative 240 cosine C left on this side. And then the 240 is attached to the cosine in multiplication. So we're going to use division to get rid of it. Ooh, that's rough. Let me try that again. Okay, and I'll just finish the rest over here. 180 divided by 240 is 0.75. And then to undo cosine, we need to use inverse cosine. So that gives us angle C is 41.4 degrees. Which is actually the angle that they were asking us to find, which is perfect. So if you labeled A, B, and C differently, you would have gotten a different angle. So for example, if you labeled angle J, letter C, you would have found vertex J. And then you could either use law of sines, or you can use law of cosines again to figure out that angle. But if you're choosing things wisely, you won't need to do that. So I labeled angle C, the angle that we were looking for, so things worked out. But again, you could use law of sines next to figure out another angle and find it what you need that way. All right, number 8 just wants us to subtract our functions. This is the notation for function subtraction. So f minus g of x just means 12x minus 9 minus 4x minus 3. And make sure you are subtracting both of these terms. And we subtract like terms only. So 12x minus 4x, because those are like terms, and then 9 minus negative 3. This really gives us 12 minus 4 is 8x. And then 9 minus a negative 3. Minus a negative is really the same thing as adding. So negative 9 plus 3 is negative 6. That's your answer. Number 9 is almost basically telling us the same exact thing. It's telling us that the answer to the addition is 2x squared plus 4x plus 1. So when I add function f and function g together, I get that as my answer. So I could use subtraction to figure out what f is. I want to subtract all of function g. So if I do 2x squared minus x squared, I get x squared. 4x squared minus negative 2x is the same as adding, minus a negative. So plus 6x. And then I get 1 minus 4, which is the same thing as adding. So that's plus 5. That's how I know what function f is. Another way to think about this is to say your like terms have to give you the correct sum. So x squared plus something has to give me 2x squared. Negative 2x plus something has to give me 4x. Negative 4 plus something has to give me 1. So then you just need to figure out what those somethings are. X squared plus x squared gives me 2x. Negative 2x plus 6x gives me 4x. Negative 4 plus 5 gives me 1. And that informs what my function f should be. Okay, the remainder theorem just says that if we plug in a number and we get 0, then we know that number was a root. And we can use that number to write a factor. So all we want to do is figure out first what our roots are. And then take these numbers and plug them in to the polynomial to see which ones will equal 0. So let's plug in negative 1 first. And then make sure you're following PEMDAS. So negative 1 cubed is negative 1. Negative 8 times negative 1 squared is 1, plus 5 times negative 1 is negative 5 plus 14. So that would give us negative 1 minus 8 minus 5 plus 14, which is 0. So we know x plus 1 is a factor because negative 1 is a root. Let's try that with negative 3. Again, make sure you follow PEMDAS. Exponents first, then you can do multiplication. You don't actually need to, like, you could plug all of this into a calculator and know if it's 0 or not, but you don't actually need to solve any of this. We just need to know if it equals 0. This does not equal 0. Therefore, that is not a factor. X plus 3 is not a factor. Plug in negative 9. You can already tell this one's not going to be 0 because negative 729 minus more negative numbers plus 14, yeah, not going to be 0. Try plugging in 2. That does equal 0. So 2 is a root. X minus 2 is a factor. And lastly, 7, which should work because we have to circle 3 of these. But we'll plug it in and make sure anyways, just in case I did math wrong in the other problems. And that does equal 0, so we know this is also a root. Well, we know 7 is a root. X minus 7 is a factor. So we can actually use that same exact idea to figure out what the factors are in number 11. We know because it's a degree 3 polynomial that we need to find 3 factors. So it'll be x plus or minus a number times x plus or minus another number times x plus or minus another number. We need 3 factors. And we also know that our factors need to multiply to give us 30. So these 3 numbers need to be factors of 30, and both positive and negative numbers should be considered. So let's go ahead and list our factors of 30. We can have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5. Oops. I was counting, not doing factors. Plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 15, and then plus or minus 30. These are all the factors of 30. 3 of them need to be plugged into the polynomial to see which ones give us 0. Or 3 of them will give us 0, I should say. And then you kind of just pick. Let's pick 2. I really doubt 30 is going to work. And then just follow PEMDAS. So 8 plus 16 minus 22 minus 30. Yeah, that's not giving us 0. So positive 2 didn't work. I can still try negative 2 though. Again, make sure you're following PEMDAS. And that does work. That does give us 0. So negative 2 works. Remember, negative 2 is the root. So x plus 2 is the factor. And once you know what one of the factors is, you can actually eliminate the numbers, because these numbers need to multiply to give you 30. We know that these last 2 numbers must multiply to give us 15. So anything that's left that is not a factor of 15, we can eliminate. So 1 is a factor, 3 is a factor, 5 is a factor, but 6 is not. So you can get rid of that. 10 is not. 15 is a factor of itself, but 30 is not. So now we've limited the numbers that we need to actually test. We just need to test plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Again, it doesn't tend to be the big numbers, the extremes, so I would probably try plus or minus 3 or plus or minus 5. Let's try 3. And there's really no reason for me to pick any of these numbers. I'm just guessing and checking and seeing what works. 3 squared is 9 times 4 is 36 minus 33 minus 30. And that does give us 0. So 3 works as a root, which means I need to put x minus 3 as a factor. Again, these numbers need to multiply to give us negative 30. Right now I have positive 2 times negative 3, which is negative 6. Since these have to multiply to give us negative 30, negative 6 times positive, let me try writing that again, times positive 5 is going to have to work. You should still test to make sure that negative 5 is your root, just in case you did your math wrong. It's double check and verifying. So it'd be negative 125 plus 100 plus 55 minus 30, which is 0. So negative 5 is a root, x plus 5 is a factor. Okay, so we're talking about compositions in number 12. We're saying we're taking the output of f of x and multiplying that by 2 and adding 4. And then we're trying to figure out what happens to the parabola. So if we take an output and multiply it by a number, that's going to make the outputs grow faster. So if we think about what the parabola is doing, here's a normal parabola. If we take the outputs and make them grow faster, it actually makes it skinnier or more narrow. We can think about this in table form as well. If I plug in some numbers, Negative 1 squared is 1, plus 3 times negative 1 is negative 3, so 1 plus negative 3 is negative 2. If I plug in 0, I get 0. If I plug in 1, I get 1 plus 3, which is 4. And then I'm going to take those output values and multiply those output values by 2. So do you see how for the same input values, my output values are higher? Because they're higher, they're closer to the y-axis, making the function more narrow. So letter A is true. That is a characteristic. Letter B is asking us if the new parabola opens downward while the old parabola opens upward. Because these are both positive x squareds, they're both going to open upwards. In order for it to open downwards, it would need to have a negative in front of the x squared. It's asking us if the new parabola is translated 4 units to the right. We know this is false because in order to translate it to the right, we need to affect the input and in the opposite sign. So if I want to move right, I would need to say minus 4. So in function notation, that would be x minus 4 squared plus 3 times x minus 4 in order to move it right. That is not what the function looks like. So it does not move right. We know that adding to an output actually transforms it up. So if I do f of x plus 4 like this, that moves it up. So again, this is false. And in equation notation, that would be x squared plus 3x plus 4 to move function f up 4 spaces. And then letter D is asking us where it is on the y-axis for both functions. It's asking us what the output value is when x is 0. When x is 0, that's when we talk about the y-axis. So if I plug in 0 for both of these functions, it'll tell me what the output is. So this part is true. Do that for G as well. Make sure you're following PEMDAS. And this part is true as well. So this is a true characteristic. Okay, so we want to know what we need to do to function f to create function g. So there's a couple ways you can think about this. One way is to think about what happens to the actual equations. So I'm going to write what the actual equations are. Now, the normal absolute value function looks like this. So what happened to f of x? F of x is the normal absolute value function, but moved down 4 spaces. G of x is the normal absolute value function times 2. So instead of a slope of up 1 over 1, the slope is now up 2 over 1. So now all we need to figure out is how we go from function f to function g. I think you can already tell that your b is going to be 2. But now what about our c? How are we going to figure out what that c is? Well, you can tell that there's a transformation up 4 spaces. So we have function f and then we need to figure out how much we need to move it up. So this 2 distributes. And what do we need to add so that moves up the 4 spaces? Well, it just needs to get back to 0. So what value is going to make that 0? Positive 8 will make it 0. So C needs to be 8. So like I was saying, you can see that it's moved up 4 spaces, but because we have a multiplier of B, 4 times 2 gives you 8. So that's one way to think about it. Another way to think about it is using inputs and outputs. So let's create like a mini table for f of x. If I plug in 0 to f, I get -4. If I plug 1 into f, I get -3. I'm going to do the same thing for g of x. Use the same inputs. If I plug in 0 to g, I get 0. If I plug in 1 to g, I get 2. So what the equation is asking you to do is to compare the outputs. So when I have an input of 0, my output for g is 0, and my output for f is -4. So I get that equation. I can do the same thing for these. So when my input is 1, my output for g is 2, and my output for f is -3. So I get this equation. And now we can kind of work on both of these equations. So I have 0 equals -4b plus c, which tells me that c is equal to 4b. And I can use that information in this c. So that would be 2 is equal to -3b plus c, or we now know c is 4b. And now we have like terms, so we know b is equal to 2, which is what we suspected before. But we can use that information back here and say c is equal to 4 times b, which we now know is 2. So c is equal to 8. So there's another way to think about it. I'm sure there's plenty of other ways that you could also think about this, but there's 2 options. Okay, number 14 should be super easy. If we want the function to move to the right, we need to affect the input. We need to affect the x. If we want to move it to the right, I need to subtract and then we just need to subtract a number. So we're looking for something that has x minus a number in it in the same parenthesis. That would be C and E. Letter A says move it to the right 6 spaces. Letter B says move the function up 4 spaces. Letter C says move the function right 4 spaces and up 1. Letter D says move the function down 3 spaces. Letter E says move the function to the right 5 spaces. And letter F says move the function left 2 spaces and down 7. Okay, you should all have notes on rational functions, so that you can figure out the vertical, horizontal asymptotes, the x-intercepts, and wholes. The key for these rational functions is factoring. Factoring will tell you a lot. For example, letter A tells us there's a whole at x is equal to 1 because we had something that canceled on top and bottom. Letter B tells us we have a vertical asymptote at x is equal to 3 because that's in the denominator and it can't cancel. There's a vertical asymptote at 3. So which actually shares an asymptote with the graph, so we know that's one of our choices. So you see that you're going to need to factor C, D, and E to figure out which of those has a denominator that 1 doesn't cancel and 2 has an asymptote at either -2 or 3. So we do actually need to factor both the top and bottom to make sure we don't have something that cancels. So for C, the top factors into x plus 1, x plus 2. The bottom cancels into x minus 4, x plus 2. X plus 2 cancels, so we know we have a whole. And then 4 is not an asymptote that this graph shares. So that's not our answer. Letter D factors into x plus 3, x minus 1. The bottom factors into x minus 4, x plus 2. Neither of the bottom cancels, so we have vertical asymptotes at x equals 4 and x equals -2. -2 is one that is shared, so we know that's an answer as well. And just so you can see the last one, that is factored into x minus 3, x plus 2, and x minus 1, x plus 1. So we have vertical asymptotes at x equals -1 and +1 because those don't cancel, but neither of those are asymptotes shared on the graph. So these logs are inverses to exponentials. Your base is A, your power will be C, and that will be equal to B. You should think about logs and exponentials as something to be looked at together. So if you see a log, you should think exponential. If you see an exponential, you should think a log. It might help you understand what the problem is asking. All of these mention that C is negative. So what happens when we raise A to a negative number? Well, we get a fraction. That fraction is our B, which means we're going to be between 0 and 1. So A is our answer. Okay, Number 17 is using all three of our log rules. We have quotient rule, which changes division into a subtraction problem. Product rule changes multiplication into an addition problem. And power rule changes the power to be in front of the log. So we see that we have a power here. That power is affecting the entire parenthesis. So every time we write a log, it's going to need a 3 in front of it according to power rule. We also have division, so we're going to need to change that to a subtraction problem. And I see multiplication on the bottom, so we should use product rule as well. So this is going to be 3 log base 2 of 2 minus 3, and then I'm going to use parentheses because we have log base 2 of x plus log base 2 of y from that product rule. Another better way to write this would be 3 log base 2 of 2 minus 3 log base 2 of x minus 3 log base 2 of y, because that negative got distributed, that negative 3 got distributed to both of the logs. And an even better way to write this would just be 3 minus 3 log base 2 of x minus 3 log base 2 of y, because log base 2 of 2 is equal to 1. Again, thinking about this as an exponential, 2 to what power is 2? That power would have to be 1. So log base 2 of 2 is 1. Okay, if a linear equation has a slope of 2 and a y-intercept of negative 5, so it's negative 5 and then it goes up 2 over 1, so it looks like this. It wants to know the end behavior as x approaches positive infinity, so we're talking about the right side of the graph. What is the function doing on the right side of the graph? It is pointing up. It is going up to positive infinity. It'll go up forever. So as x approaches infinity, f of x will go up or approach positive infinity. By the way, we can make a similar statement for the left side. We can say as x approaches negative infinity, the function goes down forever. So we can say f of x approaches negative infinity. 19 kind of goes back to this problem with the graphs, the rational function, which you can recognize because it looks like a fraction. So what we want to do is factor. So if I factor the top, that doesn't factor. Awesome. Since it doesn't factor, we know it doesn't cancel with the denominator. So what we need to do is actually just use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. A is 1, b is 2, c is negative 2, and just plug that in. So negative 2 plus or minus 2 squared minus 4 ac all over 2a. Negative 2 plus or minus 4 plus 8 all over 2. So now we have negative 2 plus or minus 12 over 2. And then 12 breaks into 4 and 3. We can do the square root of 4, which is 2, but we can't do the square root of 3. And then we can divide both of those numbers by 2. So we get negative 1 plus root 3 as an answer and negative 1 minus root 3 as an answer. Both of those are roots to that function. I think on the final exam, they probably will give you something that does factor. So you would just need to factor the top and set it equal to 0. So let's say the top was actually, let's say we had x squared plus 5x plus 6 over x minus 1 instead. Then you would just say the factors of the top are x plus 2, x plus 3 over x minus 1. Nothing cancels, so there's no whole. That means your x-intercepts are at -2 and at -3. That's probably something that'll be more on the final, but I haven't looked at the final, so I'm not actually sure. Okay. So now you just need some of these properties of rational expressions. The key indicator here is that it can be written as a fraction. And we can think about what's the difference between a proper fraction and an improper fraction as well. You know that proper fractions have a smaller number on top, and that improper fractions have a bigger number on top, and then can be changed into a mixed number using division. Anything can be written as a fraction if you put it over 1. So this is a rational expression, so this would be a false statement since we can put it over 1. We're talking about a proper rational expression, so for it to be proper, it needs to have a smaller degree on top. So the degree of the numerator is less than the denominator. That is true. For example, x over x squared. That would be a degree 1 over a degree 2. Okay? This is saying we can define when the denominator is 0. We cannot divide by 0. That is not possible. So this is false. And then we have a degree 1 over degree 1. We need the top to have a smaller degree in order for it to be proper. So this is false. That is an actually improper fraction. So if it is a proper rational function, the degree on top is smaller than the degree on the bottom. So again, like x plus 3 over x squared plus 1. This is a degree 1 over a degree 2. Well, you learned some rules about horizontal asymptotes. There were 3 ways that you can have a horizontal asymptote. The first way was y equals 0. The horizontal asymptote is 0. The horizontal asymptote is a number, or the horizontal asymptote does not exist. We knew that it was a horizontal asymptote of 0 when your degree on top was smaller than the degree on bottom, and that is highlighting this situation right here. So it's saying that we're going to have our function approach 0 when we have a proper fraction. This is saying our function approaches 0 since we have a proper fraction. So this is the only one that is true. The others are false. Okay, I really hope that you do not need my help with number 22. We are dealing with the areas of triangles when half base times height. They all have the same base and they all have the same height. Therefore, they all have the same area. Okay, the probability that you are going to prefer cheese pizza is 9 out of 25 people. And we're going to multiply that by the total number of people we have. So 9 divided by 25 times 600 people is 216 people. All right, back to our rational functions. So we just talked about 3 situations for your horizontal asymptote. So we have the first situation where y is equal to 0 because we have a smaller degree on top of a bigger degree, making it proper. We have the situation where we have a a number when we have the same degree over the same degree, which is actually this situation. We have a degree 2 over a degree 2, so we're going to get a number. And we have the last situation where it's not applicable because we have a bigger degree on top than the bottom. So that's not going to work. So here our horizontal asymptote is going to be a number. In this case, that number is going to be 6 over 3. You just divide the coefficients and you get 2. So we have a horizontal asymptote at y is equal to 2. There's your horizontal asymptote. Remember that the wholes, vertical asymptotes, and zeros all come from factoring your rational function. So we need to factor both the top and the bottom. So you can use that remainder theorem we talked about before to figure out what the factors are. Or you can just think about what your numbers are going to have to be. The bottom, I think, might be a little bit easier. So I know I need a 3x and an x, and then I need these other terms to multiply to be 10. So you can just kind of guess and check. So I'm going to guess that 5 and 2, which just multiply to be 10, is what my factors need to be. So this gives me 2x, and this gives me 17x, or excuse me, it gives me 15x. Which when I add them together, it does give me the 17x. So I did guess correctly on that. And then the top, you can either try 6x and x, or, which I think is what's going to end up happening, is a different combination to multiply to be 6, so 3x and 2x. Then I'm going to guess this is 2 and this is 1 because I need to multiply to give me 2. And then I just need to check there. This gives me 4x. This gives me 3x. And if I make the 4x positive, the 3x negative, then I will get 1x here. In order to do that, I need to make the 1 negative and the 2 positive. And that also works since we want a negative 2. Positive 2 times negative 1 gives us our negative 2. So that all checks out. If you're not sure, you can distribute and see if you actually get the right values. Now notice we have factors that cancel. We have 3x plus 2 on top and bottom. So there is a whole when 3x plus 2 is equal to 0. Solving for x, you get negative 2/3. So we have a whole at x equals negative 2/3. Looking at the top, we have x-intercepts or zeros, same thing, at x is equal to 1/2, and it's 1/2 because 2x minus 1 is equal to 0, and you solve for x, you get 1/2. And then lastly, the bottom gives you your vertical asymptote. So we have a vertical asymptote at x is equal to negative 5. So I think we've got everything. We've got the whole at negative 2/3, vertical asymptote at negative 5, horizontal asymptote at 2, and the 0 at 1/2. All right, so we want to plug in 1 into F first, and then plug our answer from that into G. So here's what it'll look like all together. So plug 1 into F first, and then plug all of that into G. And you could do this one at a time. So f of 1 is 2 times 1 minus 2, which is 1 altogether, and take that value and plug it into G. Or you can just do it all together and follow PEMDAS. Up to you. Okay, so plug 0 into F, plug your answer to that into G, plug your answer to that and back into F. So here's what it'll look like all together. Plug 0 into F, plug all of that into G, plug all of that into F. So you can solve all of that following PEMDAS. Or you can plug everything in one at a time. So I can plug 0 into F, I can plug that answer into G, and then I can plug that answer into F. It is totally up to you which way you want to do this, but both ways end in the same number. Remember, these are compositions, so you take one function's output and use that as another function's input. All right, so it's really important that we're able to identify what the midline is on our graphs. Our midline is 2. So remember that when we write our functions, it is amplitude times the trig function. In this case, we're dealing with a cosine function since we start on an amplitude value. The y-axis is an amplitude. This is a cosine graph. If the y-axis was a midline value, that would be a sine graph. So it is amplitude times cosine of 2 pi over b. Actually, that's how you find the period. It is your b value here times x plus midline. What I'm trying to say with the 2 pi is your period is 2 pi over b, so that we can figure out what our b value is in our equation. Now I've just highlighted that amplitude, or excuse me, not that amplitude, that midline at 2. So we already know this value is 2. The midline value is 2. So f of x equals all that plus 2. The amplitude, we just need to count. How many spaces is it from the midline to a maximum? 1, 2, 3. Or from the midline to a minimum? 1, 2, 3. So our amplitude is 3 in this case, and it is positive 3 since we are starting on a maximum. Again, we know it's cosine. Maybe I should write that. We know it is cosine because it starts on the y-axis on an amplitude. And now all we need to do is figure out what our b value is. So my period on this graph goes from here to here. And how do we know? Because we count 5 points. 1, 2, 3, 4, 5. We count the amplitudes and the midlines out 5 spaces, and it tells us what our period is. Our period is 2 pi. So our period is 2 pi, and we know that is equal to 2 pi over b. What value does b have to be in order to make this a true statement? B would have to be 1. So that 2 pi is equal to 2 pi over 1. The other way you can think about this is to actually solve. So I can make this a proportion and cross multiply. So 2 pi b is equal to 2 pi, and then you have to divide by 2 pi, and that gives you 1. Another way to think about this is that the parent function has a period of 2 pi. So the parent function is just cosine x, and that has a period of 2 pi. Because our transform graph also has a period of 2 pi, we don't need to change the value in front of x. So it is just x here. So a few different options for you. There you go. That's the equation. Nothing else has happened to it. Okay. Our midline is 0. So we don't need to add anything. Our amplitude is 1. So there's no number in front of our sine or cosine graph. Now, I would say that this is a sine graph because we start on a midline value on the y-axis. But it's not a normal sine graph because sine graphs usually start up and then come down. So what happened? The equation is negative. And our period is 1, 2, 3, 4, 5 is still 2 pi. To make this a cosine graph looks like this. Oops, let me try that again. So we have a little shift going on. We need to shift to the left. So we know when we're shifting to the left, we need to add. So now we just need to figure out how much we're adding to our input. Well, this whole section is pi. That much is half of that. So pi over 2. There you go. That's it. Number 28 is a unit circle question. You need 2 angles in degrees and 2 angles in radians that lie in quadrant 4. Quadrant 4. This is quadrant 1, 2, 3, and 4. Quadrant 4 lies between 270 degrees and 360 degrees, so any value between 270 and 360 would work. So for example, you could do 271, 359, 282, anything between 270 and 360. And then if you remember your unit circle, anything between 3 pi over 2 and 2 pi for radians will work. 11 pi over 6 is in that quadrant. 5 pi over 3 is in that quadrant. And then 7 pi over 4 is also in that quadrant. So any of those radian values will work. An even function is symmetric about the y-axis. Oops, too many. So that'll look like a parabola, where it looks the same on both sides of the y-axis, just flipped. Another property of an even function is if you plug in a negative value, you have a negative input, you'll get the same output as if you plugged in a positive input. And that should make sense to you. If I plug in -2 here, I'm going to have the same output value as if I plug in positive 2 here. It's the same level, same height. An odd function is a rotation of 180 degrees. So it'll look the same if you rotate it 180 degrees. An example is the line y equals x, or actually any line that goes through the origin through 0, 0. Another example might be some sort of cubic like this. If you were to flip the screen over now, it'll look the same. Sorry, that was a really bad drawing. It's a little bit better. Forgive me, drawing on a screen without a grid. So if you were to turn the screen over 180 degrees, this graph should look the same as the normal orientation. And for this, if you plug in a negative input, you'll get the opposite of plugging in the positive input. So if I plug in -1, I get a positive value, but if I plug in +1, I get a negative value. So it's kind of like the opposite. And then I changed number 30 a little bit because there was not a right answer. B and C actually looked the same. In order for it to be an even function, we need it to be symmetric about the y-axis. This is symmetric already because it kind of just looks like your parabola. This one just moves it down 3. Moving it down 3 spaces is still not going to affect the y-axis symmetry. This is just flipping it over and making it more narrow, so that doesn't affect the y-axis symmetry either. So A, B, and C, those are all even functions. They didn't give you a correct answer choice. So I changed it on this copy so that you would see that moving it to the right 3 spaces no longer has symmetry about the y-axis. So this would be a function that is not even. Okay, in order to combine two fractions, you already know that you need a common denominator. We don't have a common denominator here. However, we do have a common denominator between these two. So what I'm going to do is I'm going to take this one and move it over to this side. So in order to move it to that side, you need to add 1 over x to both sides. So that cancels. You have 2 over x plus 2 is equal to, now I can combine these two together and get 2 over x. Now, because we have a fraction equals a fraction, we actually cross multiply. So we get 2x plus 4 is equal to 2x. This statement is never true. So we have no solution. Letter B is a little bit more complicated because these don't have a common denominator. And there's no way to move it over so that it has a common denominator. So what we're going to do is we're going to multiply by the other denominator, the one that we're missing. So this denominator is missing the x plus 2, so I'm going to multiply this whole fraction by x plus 2. And this fraction is missing the x minus 2, so I'm going to multiply this entire fraction by x minus 2. So we get 5x, and don't forget to distribute, plus 10 over x plus 2, x minus 2. And then the other one, don't forget to distribute, that's 7, will become 7x minus 14 over x plus 2, x minus 2. And then we didn't do anything to the other side, it is still 10x minus 2 over x squared minus 4. What we want to do now, since we have a common denominator, is to add the numerators at the tops. So that'll be 12x minus 4 over, and notice if you multiply these out and distribute, you actually get x squared minus 4. Ooh, too much. Oops, sorry. Okay, sorry, needed more room. So now we're going to cross multiply. And then we have the same factor on both sides, so that factor cancels. And now I need a lot more room. Sorry, guys. That should work. So now we just need to solve our equation. 12x minus 4 is equal to 10x minus 2. I'm going to subtract 10x from both sides. And then I'm going to add 4 to both sides. So x is equal to 1. And you do want to make sure that your answer is not going to make the denominator 0 on any of these. If I plug in 1 in the denominator, none of them equal 0, so that is a valid solution. That is the correct answer. C is a little bit nicer because all we need to do is cross multiply. So I get 9x is equal to 4x minus 8. Don't forget to distribute. Subtract that 4x from both sides. So x is equal to negative 8/5. Again, you want to plug your answer into the denominators. Make sure none of them equal 0. Neither denominator is 0, so that is a valid answer. That is why, by the way, that is why it says check your solutions, because sometimes the denominator will be 0 and then you have an invalid answer because we cannot divide by 0. 32, a survey is just something where you're asking people questions. So just come up with a scenario in which you're asking people questions to find out something. So for example, if you wanted to know if people were satisfied by their recent car purchase, most recent car purchase, you can just go to like a dealership and ask people who just bought their car if they are happy about their purchase. An observation would be something where you're just watching people for information or watching something for information. So that could be watching how plants grow, for example. So you could see, if you're curious to see the change in plants over 30 days, you can look at a plant when it's starting on day 1 versus looking at the plant and how tall it is on day 30.